Thank you, David. Okay, so, like you said, my name is Dave Snyder. I post as Daklu on the forums. How many people here visit Lava? Yay! All right. So you've probably seen my posts. For better or worse, maybe I'll make it out of here without getting tarred and feathered by the end. I'm probably best known on Lava for long posts that give you way too much detail, and for not liking cute state machines. So we'll see how this goes. Let's see if I can make this work. Here we go. Okay, so here's what I'm hoping to cover. Let me say that I started, closer? My apologies. I started my journey into actor-oriented programming about 4 years ago with a post on Lava from Kurt Friday, I believe his name was, when he posted about a, the name just slipped my mind, active object framework that he had built. And that was what kind of got me started in the whole actor-oriented thing. At the time when I started, I didn't realize I was going down this actor-oriented path. It wasn't until about a year ago when I reconciled what I was doing with actors in general. So, Stephen, as far as I know, is Stephen in the room right now, Mercer? Wasn't it about 4 years ago when you started the actor framework?
Yeah.
Okay, so Stephen started about the same time I did. Stephen took a very direct route because he knew where he was going. I took the scenic route. And it took me a lot longer to get there. But I did get there, and I got there in a way that, to me anyway, it makes more sense intuitively. And I hope that in the next 20 minutes that I have here, that I'm able to help you understand actors on an intuitive level, and help you understand that they're really not that complicated, and many of you are probably already doing a lot of actor-oriented type things in your code. So, I'm going to give you a few slides on actor model theory. We're going to talk about what the actor model is, why you want to use it. I'll cover there's 3 elements in the model. I'll describe those briefly. And then I'll give you a couple principles that apply to all actors, whether or not you use the actor framework or some other framework, or roll your own. These are principles that apply to actors in general. And just briefly, I'll talk about a couple different topologies for creating actors. And after that, I'll show you some code samples of how I apply actor-oriented design principles to LabVIEW. I'll show you how to map the model elements to code, and I'll give you some tips for implementing actors in your own code. All right, maybe I can control this a little bit. Okay, that's better. All right, what is the actor model? Wikipedia has a great definition of the actor model. It says the actor model in computer science is a mathematical model of concurrent computation that treats actors as the universal primitives of concurrent digital computation. And that is a fabulous definition if you know what the actor model is already. If you don't know what it is, you probably still don't know what it is. So, the translation is really what the actor model is it's a way to think about concurrent programming. It's a way to think about it in a way that helps you understand the difficulties and the issues that you have to deal with when you're doing concurrent programming. Elements of the actor model. Actors have 3 different elements. You have your actor, you have your messages, and you have your addresses. That's all there is in the actor model. Okay? So, those 3 things. An actor is a logical encapsulation of data, procedures, and threads. It's a little bit, how many people here do object-oriented programming? Fabulous. So, you understand objects are a combination of data and methods on those data. It's a higher level of abstraction than just separating the data and the procedures. Actors, in a sense, take that a step further in that it includes the data, the procedures, and the threads that those procedures run on. Messages are essentially any information that passes between actors. If you have one actor communicating with another actor, it does that by message. There is no communication between actors that is not by message. And the last part of the model is an address, which is essentially just a destination for a message. Okay, principle number 1. Actors can receive any message at any time. Let's suppose we have a few actors here, a system of actors, and they're all just kind of doing their own thing, which isn't very interesting. Actors get interesting when they start interacting with each other. So actor 1 here says, you know, I'd really like to receive some messages from actor 2. So he sends actor 2 his address, and actor 2 can start sending actor 1 messages, and they get along fabulous. However, from actor 1's viewpoint, once that happens, he no longer has control over what other actors have his address. He can't control who sends him messages. There's no way for actor 1 to prevent actor 2 from sharing his address with other actors. Once he's done that, all sorts of actors have his address. And if you recall, actors include threads. They each run on their own schedule, so they can send messages when they want, not when actor 1 is expecting to receive them. As you can imagine, that can lead to a confused actor if you don't code it correctly. So, when you create an actor, you have to be sure that actors react to all unexpected messages gracefully. I'll talk a little bit more about that later. The second principle is actors are self-deterministic. It's a little bit hard to understand what this really means in the context of code or the model. So some other ways to think about it are, the actor is responsible for itself. That means if the actor does something, the actor takes responsibility for that action. That responsibility isn't taken on by somebody else that's asking the actor to do it. Messages are always requests, and they're never commands. This is less about the way the command or request is phrased. You can phrase it as a command. What it really means is that the actor that receives the message always has the final authority to say yes or no. I will or will not fulfill that message request. And another way to think about it is that things are not done to an actor does things to itself. That means exactly what it says. If you translate that into the real world, if a turkey were an actor, come Thanksgiving we would ask it to chop off its own head.
Better yet, just tell it it's Thanksgiving.
But you could tell it it's Thanksgiving and it would just know what to do. That's another way you can do it. Yeah, absolutely. The principle here is, or the point is, somebody else isn't going up to the turkey to kill it. We're telling the turkey about situations and it's killing itself. The same is true with actors. Okay, talking about topologies. Now there's lots and lots of different types of topologies that you can use to create your actors. I really only have time to touch on 2 of them, so I'll cover the 2 most common. The first is what I call direct messaging. This is where every actor talks directly to another actor, to every other actor it wants to talk to. This is kind of the default topology that people back into, usually because they don't know any better. The alternative, and what I recommend, and I believe what the actor framework encourages also, is hierarchical messaging. Now let me talk a little bit about this. hierarchical messaging is very similar to how you envision a VI tree. You have high-level VIs that do high-level abstract things. And as you break it down into sub-VIs, each sub-VI does something more and more specific as you get down the tree. The same is true with hierarchical messaging. We have a high-level actor that only deals in high-level abstractions and commands. And in order to fulfill the duties of that high-level actor, he delegates tasks down the tree until it gets to somewhere that actually does the work. In this concept, the terminology I use is taking actor 2, for instance. Actor 1 is a super actor. Actors 4 and 5 are sub-actors. These are smaller components. And actor 2 is responsible for coordinating the activities of its sub-actors and also reporting any status up the tree. Excuse me for a second. Okay, so there are obviously trade-offs, as in all things. Direct messaging, very easy to implement. You just add an actor and you start sending messages to other things. Doesn't require much planning, and it feels very efficient because you're moving along, you're making progress, you're writing code and you're integrating it into your system. I put a big question mark next to advantages. It also has the distinct disadvantage that it's hard to understand your system. Take that back. It can be very hard to understand your system. So feel free to do that if you want. When it does something unexpected, you might want to change. Hierarchical messaging advantages: it promotes encapsulation. Every one of these nodes is effectively an entire subsystem on its own. It can be very easy to pull those out and use them somewhere else. It's also very easy to test them. It's easier to reason about the behavior, and it provides better scalability over the long term. Okay, to summarize the theory part, actors encapsulate data, procedures, and threads. Those three things. What I didn't exactly say, but which is implied by this, is that actors are parallel processes, including one or more threads. Actors cannot predict their next message, so don't expect your actors to know what the next message is. And the final point is actor design is different from actor system design. They're two separate things that you need to consider differently. Moving on to the LabVIEW part. Okay, implementing actor principles in LabVIEW. So first of all, I'm going to talk a little bit about messages. Everyone should be familiar with named data messages. They're commonly implemented as clusters. Here I have a name as a string and data as a variant. There's lots of ways to implement them. The key thing is that you have some sort of message identifier along with some payload that is the data. That's what distinguishes a named data message. The other option you have is command pattern messages. Are people familiar with command pattern? Okay. It's too complex for me to go into now. If you're not familiar with it, you can look it up online. I'll leave it at that for now. There are advantages and disadvantages to both of these as well. Named data messages, you increase your risk of runtime errors with named data messages. With command pattern messages, you increase your coupling between components. And I don't really have time to talk much more about that. Each option, no matter what you choose, each option has natural strengths. So figure out what your requirements are for your systems in your working environment and use the one that better fits your environment. Neither option has insurmountable technical issues that you need to worry about. It's just a matter of how easy it is to do what you want to do. Okay, moving on to addresses. We've covered messages, going to addresses. This is a simple one. Addresses are a message transport. So let me talk about my terminology a little bit here. I use the terminology message transport. Who went to Nancy's session on frameworks? Very many? A few? Okay, she talked a little bit about transports. The principle of a message transport is just what it sounds like. It's for transporting a message from one actor to another actor. Most of the time, it makes sense to use something like a queue or a user event as a transport mechanism. You can use other things that you may not expect would suit the transport role, but I don't want to get into that right now because it's a big rat hole. So we won't go there. And I can practically guarantee you that someone out there is saying, now wait a minute, Dave, an address defines a location, but a transport moves something around. They're not the same thing. How do you work that out? And I'll bet somebody's thinking that because that's the same thing I thought. My answer to that is, the model is a model. Don't get too hung up trying to implement the model exactly as it's presented. The model represents metaphors for how to think about things. The purpose of an address is to make sure a message gets to the right location. The message transport does exactly that. As far as we're concerned, they serve the same roles, so we call them the same thing. Okay, now we get into some interesting stuff. Implementing actors. Every actor has a brain. This is the part that controls everything else that goes on in the actor. That brain is the message handling loop. I trust you've seen this type of a structure before. Don't worry about this. This is just a DQ message. It's my own personal flavor of it, with a little bit of extra functionality. But essentially, this is name data messaging. And the other thing I want to mention is don't get too hung up on the exact implementation you see here. I'm demonstrating this in simple code in order to try and get the principles across. If you understand the principles, then you can implement it however you want. Okay, the actor's brain is a message handling loop. Again, somebody out there is saying, but Dave, that looks a lot like a queued message handler, and I thought you didn't like those. That's fair. I don't like queued message handlers, and I don't call that a queued message handler. For good reason. I think it's a good reason. You may or may not. When you use the term queued message handler, you are including information about how that structure can be used, how you should interact with it, what you can do. All these other things are associated with the name. The name doesn't just refer to a while loop with a case structure and dequeuing something. Many of those things that people do with queued message handlers are in fact thread safe only in very limited situations. And it's very easy to make them so they are not thread safe. So, and the other aspect is that why I don't like this name is because the fact that it uses a queue is largely irrelevant. You can use other structures for your message transport. You can use a notifier if you want, which doesn't have any sort of a queue. So I refer to these as message handling loops. That's the differentiation I make. And you can agree or not. Okay, a little bit of a sidebar here to elaborate a bit on my differentiation between queued message handlers, or queued state machines, and actors. First, common queued state machines, or common queued message handlers, I'm sorry. There are several queued message handler patterns out there that go a long ways towards helping you not fall into the common traps that make queued message handlers hard to work with. JKI's state machine is one of them. They do a pretty good job of protecting users from making those kinds of mistakes. In truth, there's a lot of gray between queued message handlers and a message handling loop. There isn't really a clear dividing line between the two. It's a matter of how are you using it? What kind of things are you doing with it? So this list is idealized to some extent. All right. Common QMHs, they tend to be dumb parallel processes. They do exactly what they're told every single time. Actors, smart parallel processes. They do what they're told if it makes sense for them to do it. If it doesn't make sense for them to do it, they don't do it. Queued message handlers, really those are focused on sequences. You create sequences, you pass a sequence of messages via macros. Who's used macros with queued message handlers? A few people? Okay. Yeah, I've done it. That's one of the reasons why I don't like them anymore. So the queued message handlers accept these sequences of messages in order to accomplish some larger task. The actor just takes a single message to accomplish that larger task. Queued message handlers put responsibility on the message sender. What I mean by that is, if the QMH is in a state where it only accepts certain messages, then it is the sender's responsibility to know that it is in that state and to not send it messages that it should not accept at that time. An actor takes that responsibility for itself. An actor can accept any message at any time and will know what state it's in and either reject the message or postpone it, or if it's in an appropriate state, it'll go ahead and execute. QMHs are often thread unsafe. Macros are often problematic. Priority messages are often problematic. If you're queuing messages at the front of the queue in order to give them priority, that can easily lead to problems. Sequence branching decisions can be problematic. It can be very difficult to branch predictably and accurately. Actors, on the other hand, well-written actors, are thread safe. QMHs scale poorly. As you add more cases, and you create these longer chains and more complex chains, it gets very, very difficult to understand what is happening in your QMH and to predict the outcome at any given time. Actors, because they encapsulate a lot of their functionality and don't expose it, they scale much better. And finally, QMHs encourage writing code quickly, whereas actors encourage writing code robustly. Now, that said, there are some places where it does make sense to use the QMH, in my opinion. The CLB exam is one. Prototype code, if you're prototyping code, that's going to be thrown away. It doesn't really make a lot of sense to spend time building this infrastructure if you're just going to throw it away in a day or two. Okay, so back to actors and message handling loops. I've got 4 tips to cover here that'll hopefully get you off on the right foot. Tip number 1, every time you drop a message handling loop in your code, you are creating a new actor. When you do that, be sure that you treat it like an actor. It doesn't really matter if you drop a new message handling loop on a new VI, or if you have multiple message handling loops on a single VI. As long as you treat each one as an actor, make sure that all communications between those actors are via messages and not local variables, globals, those kinds of things, and you'll be okay. I often put multiple message handling loops on a single block diagram, or multiple actors, with my UI diagrams. I find it's a pretty quick way to do it, while still maintaining the flexibility and robustness of actor-oriented design. The message handling loop is the actor's public interface. Any other actor that talks to that actor, any messages coming from an external source, have to go through the message handling loop. Don't try and backdoor it. And it's usually easiest if the message handling loop contains all the state data of that actor. Here's an example of one of my UI block diagrams, and I know it's too small for you to see. The point isn't to describe everything about it. And if you will notice my willful disregard for commonly accepted practices, like keeping the block diagram to one screen size. So in this block diagram, I have 4 different actors here. I have I call it a mediator actor at the top. That's the controlling actor for the entire UI. That's the actor that interfaces with the external components. Down below, I've got 3 sub-actors. Each of these are responsible for a different part of the user interface. Right here, I have this actor is responsible for collecting user inputs and providing those inputs to the rest of the system so they can make decisions. And then down here, I've got 2 other actors that are responsible for different parts of the display. Okay, tip number 2. Each actor entails some amount of development overhead. If you're going to put an actor on, if you're going to add an actor to your project, you have to put at least some minimal amount of effort into developing that actor before you really do anything with it. All actors need exit conditions. All actors need error handling. In particular, when we're spinning up a bunch of parallel processes, we don't want our application to exit and still leave some of those processes running. Hanging actors is a pain to try and track down. So when you create your actors, be sure to create them so that they know they can understand conditions when they should shut themselves down. Here's an example of my basic message handling template. I'm not going to go through and describe the whole thing. The important thing here is that in this template, I have a couple error handling cases. I have exit conditions, and I have a few other things there that are particular to the way that I implement actors. This makes it very easy for me to get a new actor started. I just go to my template, I drop a new template, either on an existing VI or on a new VI, and I've got everything in place to start coding up my actor. All right, tip number 3. Not all loops are actors. We have lots and lots of opportunities for parallel processes in LabVIEW, and that's good. Parallel processes are cheap for us, and it's good to take advantage of them. However, if you make every parallel process an independent actor, you're making it harder for yourself than it needs to be. Some processes just don't work well in a message handling loop, such as a continuous process or a periodic process. And by periodic process, I mean something that you want to fire every 3 seconds, say. You can use timeouts for those. Those have issues. Those contain design issues that you need to be sure to address if you want to go that route. I prefer to avoid it. Instead, what I do is I delegate my continuous processes and my periodic processes to helper loops. So what I call a helper loop is simply a parallel loop that does not have a message handler. It has limited self-determinism, meaning it doesn't have all the smarts of an actor. The message handling loop, or an actor has direct control over that loop, more so than it would have over another actor. Helper loops typically do one task very well. It's good to keep them simple so you can easily see what they do and easily verify their behavior. And finally, helper loops are not shared resources. If you use a helper loop with your actors, that helper loop belongs to one actor. There's only one actor, or one message handling loop, that talks to that helper loop. If anyone else wants to communicate with it, or use whatever service it provides, it has to go through the actor. Here's an example of a helper loop. Up here I've got my message handler. It's got a change, refresh, delay message. So it might receive this request to change the refresh delay from some external source. Down here is my helper loop that is responsible for refreshing the display. In this particular case, I used a DVR as a data storage point so that the refresh display will fire at regular intervals, whatever intervals have been set. When the message handler gets the message request, it changes the value in the DVR, which is reflected down here in the helper. That's one way to implement this type of behavior. Now, a couple things to note here. The DVR, in this particular case, is restricted to one-way flow of information. Only the message handler changes the data. Only the helper loop reads the data. I'm not having the helper loop send any data back up to the message handler through the DVR, because there's nothing regularly that allows this loop to read the DVR. So any communications that the helper loop needs to send to the message handler is done via messages. And tip number 4, actors work best when the message handling loop has to wait. In general, you want your message processing time to be much, much less than the time between messages. You want your message handling loop to wait. If your message handling loop is doing a lot of processing and messages are getting backed up on your queue, that's generally a bad sign. The purpose of the message handling loop is to receive requests and information from other actors and to make decisions. The message handling loop is not the action. The message handling loop doesn't actually do things, it makes decisions and delegates things. For practical purposes, let me take that back. Ideally, the message handling loop should handle every message instantly. In reality, we know that doesn't happen, but if you make sure your message handlers in your message handling loop are fast enough, then it's a very good approximation, and you typically don't have to worry about it too much. Most importantly, don't use the message transport as a job queue. I've seen a lot of people do this with queued message handlers. They queue up a bunch of jobs, then they have to start manipulating the queue and looking at it and figuring out what messages are on there and which message should be acted on. It gets to be a mess. Some people may have been successful. If so, I congratulate you. I have not. If you find you have to manipulate the message transport in those ways, take that as a code smell. Figure out some way to do it differently so that you don't have to do that. It just adds a huge amount of complexity that you don't need to deal with. Quick question?
Yeah. If you got something, for example, a hardware resource that might take some time to communicate with, would you put that in helper loop, or would you have it deal with that in the NHL?
Okay, so the question was, if I have some hardware I'm interacting with, would I put it in a helper loop or in an MHL? The answer is, it depends. If you want to talk about it more later, I'd be happy to. Okay, here's an example of another helper loop I have. This is a job processor. It's essentially the same pattern as the previous helper loop. I've got my message handler up here that's taking messages from some external source. Down here I've got my job processor. I've got a queue here so that when my job processor will come through here, it'll do whatever needs to be done to process that information. It'll finish, it'll send a job complete message back to the message handler. In that job complete message, the message handler gets whatever data is needed for the next job and sends it back down to the job processor. That's my preferred way to deal with those kinds of situations. That way, the message handling loop keeps track of all the jobs that are still pending, has all the information it needs to make the decision on what should be the next job without having to peek into the queue or start manipulating and popping things and rearranging things. Okay, so to go over those again, 4 tips for implementing your actors. Each message handling loop is a new actor. Put as many as you feel you need to put on there, but be sure to treat them as actors and follow the rules of actors. Each actor requires some amount of development overhead. Be prepared to put that in. Don't take shortcuts with that. Otherwise, it's not much fun. Not all loops are actors. Take advantage of helper loops. Those are the helper loops. I'll jump down here. If the message handling loop is the actor's brain, helper loops and sub-actors are the arms and legs doing the heavy lifting. That's one of the key things that helped me create robust applications, was to pull those lengthy processes out of the message handling loop itself. And then the 4th point there is actors work best when the message handling loop has to wait. Okay, so I know this is a lot of information. I also know that it was very brief and not much time. So, from my section, if nothing else, remember this. Actor-oriented design requires changing how you think. It's not the same as QSM, QMH style programming. Don't try to do too much in your message handling loop. Delegate those tasks to sub-actors and to helper loops. And finally, this is probably the most common problem that I've encountered with Qt message handlers. Actors can receive any message at any time. Make sure you implement the actor in a way that it deals with that appropriately, rather than making the developer responsible for making sure that is happening. And with that, I'll turn the time over to David Staub so he can give you all the nitty-gritty details about the actor framework.
Okay, interaction.